We're going to be covering over classifying rational numbers. The MLS keeps statistics for each professional soccer player. Their statistics determine these players' salary and playing time. The more you produce, the more you earn in play. If you are looking for Mr. Joe, he gave his professional soccer career after a head injury to be your math teacher. The header messed up his hair. The sacrifice he made for you. Yes, my nice gelled hair. So here are the players. We have Will Bruin. He can shoot 11 goals in 25 games played. So if he plays one game, what would his decimal be? So let's see. I want to turn this to the hundredths place. Out of 100. Can 25 go into 100? It goes times 4. So that's really, you can rename 11/25 as 44 hundredths, which can be written as 0 and 44 hundredths. Let's go down to Ricardo Clark. We'll come back to the others. You'll see why. Ricardo Clark. Can that go into 100ths place? It can. Can 5 go into 100? It goes in 20 times. So 3/5 can be renamed as 60 hundredths or 0 and 60 hundredths. And that's it. So let's go to Brad Davis now. Can 3 go into 100ths place? It cannot. So we have to divide these two numbers. What number do you see on the numerator? 1. You're going to divide it by how many parts? 3. Isn't 1 the same thing as saying $1 dividing by 3? It is. Can 3 go in 10? Well, first of all, can 3 go in 1? No. Decimal point. Can 3 go in 10? 3 times. Remainder is 1. I bring down to 0. Can 3 go in 10? 3 times. Whoops. Our remainder is 1. You know, it looks as though it is repeating. So it continually repeats. So we put a repeating bar notation above it. So it repeats. Let's try Oscar Bonique Garcia. Oscar Bonique Garcia makes 4 goals in 9 games played. So if he plays 1 game, how many goals will he make? So let's see. Can I go into 100ths place? It cannot. So isn't that another way to say $4 divided by 9? So you have $4, you divide it into 9 parts. 4 wholes divided into 9 parts. Each part will have how many? Can 9 go in 4? No. Decimal point. Can 9 go in 40? 4 times. Our remainder is 4. I bring down to 0. Can 9 go in 40? 4 times. Our remainder is 4. Wait. Didn't we just do that? It's repeating. Another repeating decimal. Do not forget the repeating bar notation, the 4 repeats. And last but not least, Andrew Driver. Can 8 go into 100ths place? 8 times 12, no, 96, no, it cannot. Almost. So let's divide it. So we have $5. You're going to divide it, or 5 wholes. You're going to divide it into 8 parts. Isn't that the same thing as 5 wholes, the same thing as 5 whole dollars? Can 8 go in 5? No. Can 8 go in 50? Don't forget the decimal point. Can 8 go in 50? 6 times. That's 48. 50 minus 48 is 2. I bring down to 0. Can 8 go in 20? 2 times. The remainder is 4. I'm done. No, not yet. Is anything repeating here? Not quite. So let's add another 0 here, because 5 whole is the same thing as $5, and also 5 decimal point 000 to the thousands place. Now can 8 go in 40? 5 times. So our decimal point is 0 and 625 thousandths. So the question is this. Rank the player from greatest to least. Who is the highest rating player here? Hey, there's a tie right here. Will Bruin, 44 hundredths, and 4400 with a repeating. No, it is not tie. It looks tie, but it's not. Remember, this is repeating. So that's really 444,000 now. Add another 4, really, in the 10,000ths place. You know what? If it's that way, I'm going to turn every one of these into the thousands place. 6 with a placeholder, annex 0 at 600,000. 33. Do I put a 0? Nope. Repeating bar, so it repeats. It's really 333 thousandths. Is there a repeating here? Nope. Just add it and x is 0. So, which decimal is the greatest? 4, 3, 600, 625. Andrew is the highest rated player, followed by Ricardo. Then, is it 444,000 or 440,000? Oscar is higher rated than Will by 4 thousandths. And last but not least is Brad Davis. Too bad I'm not in here, then you'll see where I would be. Which player has a terminating and repeating? So let's see. Terminating sounds like the word it ends. This is terminating. This is terminating. This is terminating. 5, 8, 3, 50, 11, 25. Which one repeats? 1/3 and 4/9 because it has a repeating bar notation. So now that we kind of remember how to turn a fraction into a decimal, either doing out of a hundreds place or dividing the numerator by and the denominator, let's talk about rational numbers. A rational number, there are different types of numbers. We have whole numbers, integers, and rational numbers. Let's start with whole numbers. Whole numbers are things like this. It starts at 0, 1, 2, 3, 4, 5, 6, and so on and so on. 7, 12, 15, 18. All of these are called whole numbers. Integers are whole numbers and their opposite. So can a whole number be an integer? Yes, because the definition of integer are whole numbers including and its opposite. What makes whole numbers and integers different? Do you notice that all these are positive whole numbers? While on the other hand, integers are positive whole numbers. Let's repeat all this. 0, 1, 2, 3, 4, 5, 6, 7, 12, 15, 18. Including its opposite. Opposite of 0 is 0. Opposite of 1 is -1, -2, -3, -4, -5, -6, -7, -12, -15, -18. So let's go back again. Whole numbers are positive. It's numbers like 1, 2, 3, 4, 5, 6, 7, 12, 15, 20, 24, 32, 39. Integers include whole numbers and their opposite. So what is a rational number? A rational number is a number that can be written as a fraction. A over B. It can be written as a fraction. So let's go back here. Can any of these be written as a fraction? Let's see. Let's use an example 7. Can 7 be written as a fraction? So we have 7. Can you write it as a fraction? You can. Isn't 7 the same thing as 7 over 1? 7 divided by 1? Isn't 7 divided by 1 really just 7? So all of these can be written as a fraction. -2 can be written as -2 over 1. What's -2 divided by 1? -2. So rational numbers can be whole numbers like 5, 6, 9, 12, -5, and its opposite, and it could be integers, -6, -12, -9. It can even include fractions like 7 over 1, 2/3, 3/4. But can it include decimals like 0 and 2/10? Wait, let's stop right there. 0 and 2/10. That does already sound like a fraction. 2/5. Sorry, 2/10. Which sounds like one that could be renamed as 1/5. So decimal, another decimal. 0 and 22 hundredths. That is a decimal, but can it be written as a fraction? 22 hundredths can be written as 11/50. So let's go back again. You have whole numbers. Let's break it down. You have whole numbers like these. All these are whole numbers. 0, 1, 2, 3, 4, 5, 6, 7, 12, 15, 18. Then you have integers that are whole numbers and is opposite. Then the biggest one is rational number. Rational numbers can be whole numbers, it can be integers, it can be decimals, and it can be fraction. So next screen, next screen, next screen, next screen, next screen. All right. So before we continue with this, I would like to draw a Venn diagram. This is a Venn diagram. So inside here, you have whole numbers. Whole numbers could be like 3, 4, 10, 12, 18, 0, 19, 25, 26. Whole numbers can go into integers. These whole numbers are part of the integer group. So what type of numbers are integers? 3, 4, 10, including its opposite, -3, -4, -10. So if you have -27, that's what would the whole number be? 27. And then the big overarching theme here is rational numbers. So can rational numbers be whole numbers? Yes, they can. That can be written as a fraction. Can it be integers? Yes, that could be written as a fraction. Can it be a decimal like 0 and 8/10? Yes, because that can be written as a fraction, 8/10 or 4/5. What about -0 and 5/10? Can that be written as a fraction? Yes, -5/10, which simplifies to -1/2. So let's begin. A whole number, or numbers are positive, 3, 4, 10, 27, 18, 19. Which can go into integers. Integers are whole numbers, all these, including its opposite. And then a rational number include all the whole numbers, all the integers, all the fractions, and decimal you can think of. So now that we have that, can you classify each one? -3. You know what? I need to go back to my Venn diagram. -3. -3. Is it a whole number? No, because it's negative. So it must be an integer. But can -3 be written as a fraction? Let's see. Can you write -3 as a fraction? -3/1. Yes, you can. So I think the answer is integer and rational number. It is 1/2. Is 1/2 a whole number? No. Is it integer? It's not a whole number. No. It's just it's a fraction? Yes. So it's a rational number. 7. 7 is a whole number, including an integer. And can 7 be written as a fraction? 7/1. So I think can be classified all three ways. And it can. Whole number, integer, rational number. Oh, let's make it a little harder. What's the absolute value of -2? What's the distance of -2 from 0? 2. Can the number 2 is a whole number. It's also an integer because it's a whole number and its opposite. And can 2 be written as a fraction? 2/1. All three, I think. And it is. -2/3. Is that a whole number? No. Is that an integer? No. But it's a fraction. So it's just a rational number. This one. What's the absolute value of -4? 4 minus absolute value of 3. 3. 4 minus 3 is 1. Can the number 1, is it a whole number? Yes. Is it integer? Because the definition of integer is whole numbers and opposite? Yes. And can 1 be written as a fraction? 1/1? It can. All. 5, whole number, integer, and rational? Yes. -6, is that a whole number? No, it's not positive. But it is an integer. But can that be written as a fraction? Yes, it can. So integer, rational. And last but not least, what's the absolute value of -7? How far is -7 from 0? 7. 7 minus 7 is 0. Is 0 a whole number? It is. Is it integer? Can you find the opposite of it? 0. And is it a rational number? It is. All three. So this is pretty much a study of what the differences between a whole number, integer, and rational number. Whole numbers are positive. Whole numbers like 8, 12, 15, 20, 24, 32. Integers are whole numbers and their opposite. So 24, -24. 13, -13. -2, 2. And a rational number is anything that can be written as a fraction. Decimal can be written as a fraction. Whole numbers can be written as a fraction. Integers can be written as a fraction. And that is the study of classifying rational numbers.